All right, formulas in 3 dimensions. Section 10.3 here. So continuing on in our 3 dimensions, we're going to talk about some of the formulas that go into 3 dimensions. Fortunately, they look kind of similar to some of the ones we had in 2 dimensions. So not really a lot of new stuff really today. First thing we're going to talk about is a polyhedron. A polyhedron is a solid formed by 4 or more polygons that intersect only at their edges. So a polyhedron is a solid formed by 4 or more polygons that intersect only at their edges. Prisms and pyramids are polyhedrons. Cylinders and cones are not a polyhedron. Okay, so prisms and pyramids are polyhedrons. Cylinders and cones are not polyhedrons. Essentially, anything that curves is not a polyhedron. Okay, it's got to be straight lines. Euler's formula is what we're going to talk about first. For any polyhedron with V vertices, E edges, and F faces, Euler's formula states V minus E plus F equals T. So what that says here is the vertices minus the edges plus the faces equals 2. Another way to write that is, kind of an easier way, is V plus F minus E equals 2. So vertices plus faces minus the edges equals 2. Is that the same equation? Yeah, all it is, I just switched 2 of them around. So that's just commutative property there. Okay, or associative property, the way you want to look at there. And again, they show you here, this one has 4 vertices, 6 edges, and 4 faces. So 4 minus 6 plus 4 equals 2. 2 equals 2. So I know for sure that's true. The diagonal of a right rectangular prism. Where do we find some diagonals here? The length of the diagonal of a right rectangular prism, where length is L, width is W, and height is H, is given by this formula. D equals the square root of L squared plus W squared plus H squared. D stands for the what? Diagonal. D stands for the diagonal there. Okay, what is that kind of similar to? Who remembers that formula might look similar to? That's very similar to Pythagorean theorem. Yeah, this one is very similar to Pythagorean theorem. It's actually kind of derived from Pythagorean theorem, really, just from the way it goes. But that is for the length of the distance for the diagonal in a 3-dimensional shape. Okay, and they go down here and they show you how you can solve it. This is if they give you the diagonal, I want you to find another part. Okay, so they give you, go walk through the examples there. Again, plug and chug, go through the information they give you. Let's try the first one here. Find the number of vertices, edges, and faces of each polyhedron. Use your results to verify Euler's formula. How many vertices does number 1 have? Frosty, how many vertices does number 1 have? There are 8 vertices. How many edges does number 1 have? Trevor? There are 12 edges. And how many faces does number 1 have, Trev? Six. So I have 8 vertices, 12 edges, and 6 faces. So that says here, Euler's formula states V plus F minus E equals 2. So 8 plus 6 minus 12 equals 2. Is that true? 8 plus 6 is 14. 14 minus 12 is? That checks out. That is true. Let's try number 2 here. How many vertices does number 2 have, Ryan? There are 6 vertices. How many edges does number 2 have, Troy? How many faces does number 2 have, Tom? 6. So I would say 6 plus 6 minus 10 equals 2. Is that true? 6 plus 6 is 12. Minus 10 is 2. That one checks out. So that's Euler's formula. Just stating that those are true, yes or no. Next part here. Find the unknown dimension in each figure. Round to the nearest tenth if necessary. So number 3. The length of the diagonal of a 6 centimeter by 8 centimeter by 11 centimeter rectangular prism. So, It wants me to find the diagonal here. Recognize.
Oh, it's failing group chat. That's what happened.
It wants me to find the diagonal here. So the equation states that it's the diagonal equals the square root of the length, width, and height squared. What's my length here? My length is... Nope, my length is... that length is 6, so I have 6 squared. Plus, what's my width? 8 squared. Plus, what's my height? 11 squared. So 6 squared equals 36. 8 squared is 11 squared is. So I get D equals the square root of 221. And the square root of 221 comes out to the nearest tenth as... Anybody? It's like 14.39.
Is it actually?
So isn't it 14.9? Oh, I was gonna say, there we go. So it's approximately 14.9. So I can find the diagonal there using that formula. Number 4 is a little bit tougher. Why is number 4 tougher? Because it gives me the what here? It gives me the diagonal. So it says 9 equals the square root of 4 squared plus 5 squared plus h squared. Why do I say h squared? Because what am I trying to find? I'm trying to find the height. So I work this out here. Now I just need to plug it or solve it for h. What undoes a square root? Square. So I need to square both sides. So I get 81 equals 4 squared is 16, 5 squared is 25, plus h squared. What do I have to do with that 16 and 25? Move them to the other side. So I subtract 16, or I can add them. I get 41, subtract 41 to the other side. I end up with 40 equals h squared. How do I solve for h now? I'd have to take the square root. What's the square root of 40?
6.17.
Isn't it 6.3? It's about 6.3. 6.3 right there. So that height has an approximation of about 6.3. Okay, nice job. Take up second, try numbers 5 and 6. All right, so number 5 here. How many vertices does number 5 have? Caprio.
Number 5 has 5.
How many edges does it have?
Me again.
Yeah.
8.
How many faces?
5.
So 5 plus 5 minus 8 equals 2. Checks out. Number 8, or 6, sorry. How many vertices does it have, Camden?
8.
How many edges does it have, Camden?
12.
How many faces, Camden?
6.
So 8 plus 6 minus 12 equals 2.
Yeah.
And checks out. Nice job. Alright, next part we're going to talk about is formulas in 3 dimensions. A 3-dimensional coordinate system has 3 perpendicular axes. There is the x-axis, the y-axis, and the z-axis. You'll get into a lot more in depth on this when you get to Algebra 2. This is kind of just a precursor. But x, y, and z-axis, 3 dimensions. Instead of ordered pairs, this now gets into what's called ordered triples. X, y, and z is used to locate a point. Okay. Distance formula and midpoint formula. This is what the 2 things we're going to be focused on today. Recognize distance formula. Does it look very similar to the already distance formula you know? What's the only thing they've changed? They added the z parts. Only difference. Otherwise, the rest of that's the exact same thing. Same with the midpoint. What's the only thing that's different? Added the z's. Otherwise, everything is still the exact same from what you already know about midpoint and distance formulas in 2 dimensions. So as we look here at an example, find the distance between the points 4, 0, 1 and 2, 3, 0. Then find the midpoint of the segment. Again, I just look for the distances. What's the difference from 4 to 2? Well, I get 2 squared, 4. Difference from 3 to 0 is 3. 3 squared is 9. Distance from 0 to 1 is 1. 1 squared is 1. Add them. 4 plus 9 is the square root of 14. Square root of 14 is approximately 3.7. And then midpoint. Add up the x's, divide by 2. Add up the y's, divide by 2. Add up the z's, divide by 2. And I get my midpoint coordinate. Okay, that's what we're looking for here. So number 7 here. Formulas in 3 dimensions. Find the distance between the given points. Find the midpoint of the segment with the given endpoints. Round to the nearest tenth if necessary. First thing I'll do is I want to find the distance. So I want to subtract my x values first. What's the difference from 6 to 0? So I have 6 squared. Y values. What's the difference from 0 to 8? So I have 8 squared. Z values. What's the difference from 0 to 2? So I have 6 squared plus 8 squared plus 2 squared. So D here. Square root of, what's 6 squared? 8 squared. 2 squared. So 36 plus 64 plus 4 is? What's the square root of 104? That's approximately 10.2. One of these days you'll get one. One of these days. And then I do the midpoint. Same with midpoint. Now midpoint I'm going to add and divide by 2. Notice the difference. Distance you subtract. Midpoint you add and divide by 2. So when I do my midpoint, what's the midpoint of my x values? 6 plus 0 is 6. 6 divided by 2 is 3. Then I do my y values. 0 plus 8 is 8. 8 divided by 2 is 4. And then I do my z values. 0 plus 2 is 2. 2 divided by 2 is 1. So I get 3, 4, and 1.
Couldn't you just divide the right one by 2?
Just because it's 0, 0, 0, so that doesn't always happen. Okay, now it's number 8. First thing I'm going to do is identify my distance here. So let's look at my x values. 4 to 0, what's my difference? 4, so it's 4 squared. Plus, now I do my y values. 6 to 8, what's the difference? So I get 2 squared. Plus, then I do my z values. 0 to 0, what's the difference? Okay. So distance here. 4 squared is? 2 squared is? 0 squared is? 16 plus 4 gets me the square root of? Square root of 20 comes out to be approximately? About 4.5 because we're going round to the nearest 10. About 4.5. And then the midpoint. Midpoint again. Add and divide by 2. If you add your x values and divide by 2, what's the midpoint of the x values, Noah? Y values, Noah? And the z values, Noah? There's midpoint distance. Do you all agree that's very similar to what we've already been doing for midpoint distance? Yeah, very, very similar. Try numbers 9 and 10. Find the midpoint distance of these coordinates. Take a couple seconds. Try these on your own. So number 9 here, I got distance. What's the difference in my x values here? Difference in the x values is 2, so I get 2 squared. Difference in the y values is 1, so I get 1 squared. Difference in the z values is, so I get 3 squared. When I add them all up, what do I get? Square root of? Square root of 14. Square root of 14 is approximately 3.7. Then I have my midpoint. Midpoint, add them up and divide by 2. Where's my midpoint going to be located at? No. No, where's the midpoint at? Yeah. Nice job. And then, what's up? Number 10 here. I need to find the distance. Okay. So distance here. Look at my x values. What's the difference from 2 to 3? It is? So I get 1 squared. Plus, difference in my y values. 4 to 3 is? 1. So I get 1 squared. Then I do my z's. Difference from 1 to 5 is? 4 squared. 1 squared plus 1 squared plus 4 squared gets me the square root of? Square root of 18 is approximately? 4 point what? So 4.2. Thanks. So we're on the nearest tenth.
So you're going against what system?
A midpoint. Where's the midpoint going to be at, Tom? Whoa, what? You got to add them divided by 2.
Oh.
So my midpoint's actually at what, Trevor?
2.5, 3.5, 3.
Nice job. So there's the distance to midpoint. Again, very similar to the 2 dimensions distance midpoint. Here's your assignment.